Welcome to the training module on Honeywell Microswitch's basic switches. This training module introduces the features and benefits of Honeywell's basic switches. Basic switches are the first consideration for simple or precision on and off application needs. The standard precision portfolio includes large-size basics, miniature and subminiature switches. Precision snap-action mechanisms are available with a wide variety of actuators and operating characteristics. These products are often ideal for applications requiring compactness, lightweight, accurate repeatability, and long life. They are best used for presence or absence detection where physical contact with the object is permissible. They are low cost, universally accepted, and easily understood. The heart of a basic switch is its snap-action design, recognized as the beginning of the entire precision switching industry in the 1930s. The need at the time was for accuracy and repeatability, requirements that are still prevalent today. The original basic switch was used to provide thermostatic accuracy in a poultry incubator. Today, it is represented by thousands of variations which are satisfying hundreds of thousands of applications. The original thumb-size housing has been accompanied by other smaller sizes to fit precision switching in smaller and tighter places. By definition, a precision snap-action switch is a complete and self-contained switching unit. It is a mechanically operated electrical switch having predetermined and accurately controlled characteristics. These switches are actuated by a pin plunger, over-travel, or lever actuators. With the plunger of a basic switch in the completely released or free position, the common contact is against the normally closed contact. In this condition, the normally closed circuit of the switch can carry current. This means there is electrical continuity between the common terminal and the normally closed terminal. The common terminal is electrically insulated from the normally open terminal. As the plunger is depressed, it reaches the operating point. The distance between the free position to the operating point is called the pre-travel. At the operating point, without further movement of the plunger, the common contact accelerates away from the normally closed contact. Within a few milliseconds, the common contact strikes, bounces, and comes to rest against the normally open contact. Because the mechanism is designed for a snap action, the common contact cannot stop halfway between the normally closed and normally open contacts. The normally closed circuit is now open and the normally open circuit is now closed. As the plunger is depressed past the operating point, the normally open circuit remains closed and the normally closed circuit remains open. Basic switches can be used in a broad range of industries, including instrumentation, industrial, medical or dental, infotech, HVAC, white goods, vending machines, and aerospace. The SM Subminiature switch, first introduced in 1950, was Honeywell Microswitch's first attempt at true miniaturization in electrical switches. It became the forerunner to the entire subminiature switch industry. Its superior design, coupled with microswitch manufacturing techniques, led to further miniaturization and the introduction of many product families incorporating similar SM capabilities in construction. The Subminiature basic switch portfolio includes the SM series, the SX series, the U series, and the Z series switches, as well as the EM, HE, and HR sealed switches. Along with the miniature size associated with the subminiature switches, several other attributes are key. The cover and case construction has molded-in terminals. The operating force is as low as 2 ounces, and differential travel is as low as 0.001 inch. The switches have temperature capabilities up to 250 and 400 degrees Fahrenheit, and they have a variety of integral and auxiliary contacts. They meet international agency approvals, including UL, CE, ENEC, and CSA. The UM, ZV, and ZW product lines are also environmentally sealed. There are several benefits to these attributes. The lower operating force provides very precise operation and application versatility. The environmental capabilities provide reliable switching under high temperature and other environmental conditions. Having a covered case construction with mold-in terminals allows for very simple adaptation to the customer's actuating systems. This saves customers time and cost in purchasing inventories and assembly operations. The molded-in terminals also reduce the possibility of a switch cavity contamination. Finally, the international certification is helpful in getting the customer's equipment agency approved. The V line of miniature basic switches includes more than 2,000 individual catalog listings. These are aimed at solving a wide variety of switching applications in multiple markets. The total line consists of two main families, the V5 series and the V7 series. The V series features a wide range of options and operating characteristics, including integral levers, electrical ratings, temperature ranges, and types of contact material. The V series is very easy to install and troubleshoot as it has 4 quick connect terminal variations. V series switches are not susceptible to EMI or RFI. The products are designed to meet international standards so that they can be used on all products and customer equipment requiring conformance on these standards. Those approved ratings are marked right on the switch, showing the customer that we meet all of the approval requirements. V-Series products are differentiated by a number of factors. In random quality audits, switches are periodically selected at production lots and evaluated for switch resistance, dielectric strength, insulation, mechanical and electrical life. This ensures that product quality is always maintained and monitored. The products can accept insulated connectors and all popular quick connect receptacles. A thermoplastic housing is used and it makes the switch cleaner initially and over its life, resulting in more stable switching. The more resilient material also holds the terminals tighter, resulting in better repeatability over the life of the switch. The B-Series product was originally designed in 1932 by Philip K. McGall. McGall refined the design of the switch, and in May of 1934, a patent was granted. Today, the product line remains basically unchanged. The BZ and BA type switches are close relatives of the original microswitch product introduced in 1932. They have been used in countless applications requiring precision power load switching. A variety of offerings, quality, and time-proven performance account for their popularity in continuing large volume sales over the years. The BZ switch meets most application needs. Modifications of the standard silver contact design and material, spring configuration, and plunger locations give the type BM, BA, and BE switches greater electrical load handling capability. Other changes in materials and switch design provide operating characteristics, temperature tolerances, and sealing to cover a wide range of special requirements. The large basic switch portfolio includes the BA and BE series, as well as the BZ and BM series. Large basic switches offer a broad range of electrical ratings, operating action and terminations, and a wide selection of actuators, operating characteristics, and circuitry options. All add up to give you mechanical and electrical versatility that goes from milliamps up to 25 amps and temperature ratings as low as -65 to 400 degrees Fahrenheit. These switches have many agency approvals including European, UL, CSA, military standards, FAA, or PMA. Large basic switches, through the use of optional sealed plungers and covers, are also capable of an IP67 rating. Key differentiators for the product are the mechanical life of up to 20 million cycles, a long electrical life, and the ability to have electrical ratings of milliamps up to 25 amps. The housing has an elongated mounting hole for easier, more accurate mounting and interchangeability. From outside, many switches might look alike or even identical. Looking under the proverbial hood of any switch you are considering in your design can help you make an educated decision of the basic switch for your application. The first step is to check case specifications. A superior switch case is thickened and contains a high level of glass filler to make it less susceptible to cracking or breaking. Switch cases made from 100% regrind plastic typically do not tolerate harsh operating conditions or high cycle rates and may have lower melting points and poor heat dissipation. A reputable switch manufacturer will provide regrind and glass-filled contact. Case design is equally critical. Look to see if any components might be overexposed. Next is to look for cycle life specifications. If not listed, ask for test results. It's a good practice to specify a switch with a significantly higher cycle life than you anticipate it will see in your final application. Look at the common terminal, connecting terminals, and leaf spring. Silver plating delivers superior heat dissipation. Gold plating is required to prevent corrosion in low current switching applications. Next, look at the inside of the cover. A superior switch has the locator pins to precisely align the body to the cover. These pins help keep all the components aligned to deliver consistent operation from the first to the millionth actuation. There are another two key features to check for. One is to examine leaf spring design, materials, and specifications. Another is to check for leaf spring for burrs, rough edges, and micro cracks in the high stress area.